welcome to chemistry class with Chem Chris. So we are talking about chemical combination part 2. Under this, we want to talk about naming simple binary ionic compound. How do you name simple binary ionic compound? If you're a chemistry student, understand that writing and naming ionic compound or chemical formula of compounds is very, very important as a student. Like, before you can start solving geometric calculation, like any calculation at all, you must first understand how to write chemical formula. Not only that, you must also learn how to name chemical compounds too. So in this video here, I want to teach you how to name simple binary ionic compounds. So I'm going to talk about metals with single oxidation states, then metals with multiple oxidation states. They want to look at what polyatomic ions. So it's going to be a well detailed, dense video because I really want to explain the concept. Now, the main reason why this video will be so lengthy is because I really want to explain every single details for you. I've done the first part of this chemical combination when I explained details step by step how to write binary ionic compound. I talk about, so if, for example, now let's just try to do a recap. Then we have to look at I'm going to teach you how to name them, right? So now let's say, for example, aluminium and oxygen, they are combining, and then you have been asked to write simple binary ionic compound between aluminium and oxygen, right? Now, how do you do that here? You make use of their oxidation state, because we talk about ionic compound. What is ionic compound? Ionic compound means what? The ionic compound means what? The compound between metal and non-metal, right? And when they combine together, they want to obtain the octet electron. So they exhibit what? They obey the octet rule. Now, what is octet rule? Octet rule state that atoms will lose or gain electron in order to obtain the 8th electron configuration in the atom's shell, right? So, for example, if you look at sodium, now let me give you a brief explanation on this here. If you look at sodium, if you look at aluminium here, aluminium, the electron number is 13. Aluminium, the electron number is 13, right? And if you should use the old electronic configuration, which is what? 288. This is called old electronic configuration, right? If you should use it here we have 283. What does it mean here? That is 2 electrons will be in the first shell, 8 electrons will be in the second shell, and 8 electrons will be in the third shell. 13, right? So let's fit 13 here. Here we have 2 here. If 2 should enter here, what do I have left? I have if 2 should enter here, also have 8 should enter here, right? So 2 plus 8 is 10. How do I have left is 3, right? Now, for aluminium to obey the octets, you have to lose this atom's share electron, right? Now, when you lose the atom's share for electron, it now becomes Al3 plus I there. So now, aluminium here is 283, right? But aluminium 3 plus is 2 8 to obey the octets. You see that? Now, for oxygen here is oxygen is 8, right? If you write the old electric configuration here, like you're going to be 2 6, maybe 8. So you have 2 and 6, making what? 6 electrons in the atom's shell. Now, oxygen want to behave like this guy here, so you have to gain 2 electrons. Now, when you gain 2 electrons, you got O2 minus. Are you there? Do you understand? So this will now become what? 2 8. Do you see that? So now, when you are writing chemical formula between 2 atoms or 2 elements here, therefore you have to know their oxidation state, right? You must know their oxidation state. There you have solved almost 9% of your problem. So now the oxidation state of aluminium is 3 plus. That is 3 plus means that aluminium lose 3 electrons, right? The oxidation state of oxygen is 2 minus. That it gain 2 electrons. This is that. So how do you now combine them to get the chemical formula? It's very easy. So what are you going to do here? So going to be Al, which is 3, right? O, which is 2. This guy will move here, and this guy will move here, right? What are you going to get? You're not going to get Al2O 3. Is okay. This is the chemical formula between aluminium and what, and oxygen. Hope you understand. Now, in my first video, I have done a lot of this stuff here, which I'm not going to try to go back to again in this video here, because it will be like a waste of time to us. So if you want to get that video here, I will leave it at the comment section or at the description, so I can go check out that video, right? But in this video here, I want to show you how to name simple binary what ionic compounds, and compare with what, with variable oxidation states, like metal with variable oxidation states, and polyatomic what, ions, right? So now the simple formula I want to give to you here. To write simple binary ionic compounds is very easy. To write simple binary ionic compound, please pay close attention here. To write simple binary ionic compound is very easy. Now, I have a simple formula I normally use that I've derived to what, name simple binary what, ionic compound. So what is the what formula here? So if I say formula for naming binary ionic compound. Okay. So you cannot say what name is also what. So you can say that name of what, of metal. Idea, name of metal plus stem of non-metal plus what, IDE. Is okay. Now I will explain it again. The name of the compound equals what, name of the metal plus stem of what, non-metal plus IDE. So what I want to do here, I want to give you common stem of what, non-metal. So I want to look at common stem. Right there, common stem, like the common one you are going to see, common stem of non-metals. Right there, common stem of non-metal. So here we have elements. Right? Then here we have the stem, and here we have formula. Right there, here we have what, formula. So please take this down, very important. These are things you are going to use all the time when you are what, naming simple binary what, ionic compound. So the first one you want to look at is what, is oxygen. Right there, oxygen, and the stem of oxygen is what, is O's. Right there. So whenever you see oxygen here, the stem is called O's. You understand? Now the formula is what, is O2. What does it mean here? It means that it have lost 2 electrons. Just like it have lost 2 electrons, because I'm talking about stem of what, non-metals, right? Then the next one you're going to see is nitrogen. Right there, nitrogen, and stem of nitrogen is called nitro. N-I-T-R-O. Right there, N-I-T-R-O. Yes, nitro is what, N3 plus. So nitrogen is always what, N3 minus. Yes, N3 minus. That is nitrogen. Now next we're going to be on fluorine. Right there, the stem of fluorine is called flow. Right there, flow, and the formula is what, is F what, minus. Right there, what does it mean here? That fluorine have what, gain 1 electron. That is mean, yeah, also gain 2 electrons. Nitrogen gain what, 3 electrons. This one gain what, 1 electron. So here we have flow with fluorine. Next one I want to see sulfur. Now sulfur is called sulf. Right there, sulf is what, S2 minus. This is that S2 minus. Here we have sulf here. Then next we're going to be phosphorus. Right there, going to be phos. P. That is it. The stem is called phos. Now is what, P3 minus. Here we have P3 what, minus. Next one I want to see is called chlorine. Hi there, chlorine. And it's called chlor. This that is what? Cl minus. Next one you are going to see. Next one I want to see here is the bromine. Hi there, and it's called brome. Hi there, it's called brome. And here we have B what minus. So we also have what called the iodine. So here we have iodine. Here we have iodine. So we call iod. Called I minus. Okay. So these are the common terms you always make use of when it comes to what? Binary, simple, or simple binary with ionic compound. Just that. Now, let's apply this formula here because here we have name of metal plus steam of non-metal plus ID. So now let's take this guy here. Al2O3. So how do you know metal? How do you know non-metal? Right? Sorry, how do you know ionic compounds? Ionic compound is a combination of what? Metal and what? Non-metal. So as a student, you must know what's called metal and what? Non-metal. Now, by the time you get to the periodic table, now the S block, the first group, the second group, and third group, they are all metals. Plus the transition elements. All transition elements are what? Metals. Right there. But from the other side, but from the other side of what periodic table, they are what? Non-metals. Just that. So when you combine metal and what? Non-metal, it's called ionic compound. Do you understand? So in your exam, you'll be given different type of compound. You say which of this is what is ionic compound? Right there, which of this is what is covalent compound? Which of this is called dative covalent compound or coordinate compound? Do you understand? So these are things you need to know when it comes to chemical what bonding. So now let's start with this one here. Now, if they should ask some people to name this thing in the exam, or they should name it here, they will fail completely here. They'll say tri aluminium, no, di-aluminium trioxide, which is wrong. You don't name it like that. Now, the way you name covalent compound is not the same way you name what ionic compound. So this is the formula to name what ionic compound. As far as ionic compound, as far as what binary ionic compound, this is the formula what you make use of, right? So it's very easy here. So how do you name it here? Name of metal. Al. What is the name of Al? Is aluminium. So it's going to be aluminium. Aluminium plus steam of non-metal. Non-metal here is oxygen. Non-metal here is oxygen. What is steam of oxygen? O's. So we have O's plus IDE. It's okay. So when you combine it together, it's going to be aluminium. Aluminium. You combine these two together, oxide. So the name of this guy is called aluminium what? Oxide. Aluminium what? Oxide. It's very easy. Now, if for example here we have Na2O, right? How do you name this guy here? How do you name this guy? It's very easy. It's very, very easy. The name of this guy is going to be what? Sodium plus what is the steam of what? Oxygen? It's called O's plus IDE. It's okay. So the name of this guy here is called sodium oxide. Sodium what? Oxide. Sodium oxide. Sodium what? Oxide. That is name. Now in the first video here, I've taught you. We have done how to name this one here. So if you don't know how I got this formula here, please check out the first video. It's very, very important. Now let me just throw a little light on how I got this one here. Now remember sodium. The oxidation state is +1. It's okay. The oxidation state of sodium is +1, right? Therefore, oxygen is what is 2 minus, right? So when you combine it together, Na, which is what is 1, oxygen, which is what is 2. This guy move here. This guy move here. Here we have what Na2O1. Is okay. So the name is what called sodium oxide. It's called sodium what? Oxide. Now let's name other ones here. If for example here we have this guy, here we have Mg2, Mg3, N2. Yes, Mg3, N2. So what is the name of this compound here? Is an ionic compound. I see an ionic compound here. Magnesium is a metal. Nitrogen is a what? Non-metal, right? So how do you name it here? It's very easy. Now magnesium, what is the name of Mg? It's called magnesium plus what? Now N is what? Is nitrogen, right? What is the term of nitrogen? Was ninth plus what? IDE. Is okay. So when you add them together, you're going to be magnesium nitride. Magnesium nitride. Do you see that? As easy as that. So this how you name. Look at something here. This how you name compound that contain metals with single oxidation state, which I'm going to explain more, right? But now let me give you some for you to attempt yourself. Let me give you some for you to attempt yourself. Let me give you some for you to attempt yourself. So now this is what your first trial. Go ahead and name all this stuff and leave them at what comment section. It's very important. Now look at something here. When you look at the metals you are seeing, please go ahead, pause the video here, go ahead and drop your answer at the comment section. It's very important to do that. It's okay. Don't ignore this here. Go ahead with what I've taught you here. You should be able to name all this compound here, right? Now, these are metals with single oxidation states. What do I mean by single oxidation states? Like calcium, we look at calcium here. The oxidation state of calcium is just what? Ca2 plus. I there, just Ca2 plus. So now when you're naming something like this here, you don't include the oxidation state of calcium. Like aluminium here, the oxidation state is always at A3 plus. I there. Now there's no way you can see Ca plus. It's not possible. It's not possible. There's no way you can see Al plus. It's not possible. So these are metals that have single oxidation state, like sodium Na is what? Na plus. Na what? Plus. Right? There's no way you can see Na2 plus. It's not possible. This is that. So the group 1 elements, the group 1 element, the group 2 element, and the group 3 element, they only have single oxidation state. They don't have variable oxidation state. Just and so they can only form one type of compound with a certain what? With a particular what? No metals. Just and so look at something here. But we have the transition metals. Transition metals, they have variable oxidation state. Now, one of the characteristics of transition metals is that they have variable oxidation state. They have variable oxidation state. So now look at something here. So look at what some of the common transition metals and their oxidation state, with their variable oxidation states. So here we have iron. Iron can be what? +2 and +3. It means that iron can lose 2 electrons. It can also lose what? 3 electrons. Do you understand that is meaning? Chromium, it can lose 2 electrons. It can lose 3 electrons. It can lose what? 6 electrons. Manganese is even having more oxidation state. +2, +3, +4, +6, or +7. Copper, which is common one, if you are going to see more, you what? +1 or +2. Vanadium is what? +2, +3, +4, +5. Titanium is what? Is +2, +3, +4. Cobalt is what? Is +2 or +3. So these are the common ones I will see. These, I want to see this one more. you're still going to see this one more. You're going to see copper more. You're going to see cobalt more. Zinc only have one oxidation state because zinc 2 plus. Let me check. Yes, zinc only have one oxidation state, which was zinc 2 plus. I there. So now let us say that iron is combining iron Fe is combining what with Oc, right? Now iron can use +2, iron can use what +3 in the oxidation state. Right there. Iron can use +2 oxidation state, iron can use what +3 oxidation state, right? So iron can form variable compounds with oxygen. So remember, oxygen just what O2 minus, right? But iron can be what 2 plus. Right there. If iron is 2 plus, what is the chemical formula? What is the Ionic formula between iron 2 plus and what oxygen 2 minus? Right? So going to be Fe, which is what is 2, O, which is what is 2. What up here? The two can go, right? 2 go into the 1, 2 go into the 1. So what do you have here? Here we have this guy and what and this guy. So what are you going to get here? Going to be FeO, right? Which was FeO. What does it mean here? That is the oxidation state of iron here is what is 2. That is meaning. Now what about if you use what +3? So going to be Fe3 plus and what O2 minus. Right there. Then here, what are you going to get? Here we have Fe, which is what is 3. O, which is what is 2. This guy move here. This guy move here. What are you going to get? Give now what Fe2O3. Now, as a student, this is very, very important. This is very important. So, what will not be the name of this guy? What will not be the name of this guy? Right? This way, you are not going to include the oxidation state of iron. Right? So, the name of this guy is going to be iron 2 oxide. Is okay. Iron 2 oxide. Then the oxidation state of iron here is called 2. What about this one here? It's going to be iron 3 oxide. Here going to be iron 3 oxide. Right there. Now it will be in what? In Roman figure. So they call iron 2 oxide, iron 3 oxide. Why? Because iron have what 2 oxidation states. If for example here, calcium, let's just say calcium and what an oxygen, right? When two of them combined, it is what? CaO. Now you cannot say calcium 2 oxide. No, it's going to be calcium oxide. Calcium oxide. Now, why is it just calcium oxide? Because calcium only have 2 plus. Calcium do not have variable oxidation states. Hope you understand. Calcium do not have variable oxidation states, so it's going to be calcium oxide. But here it's going to be calcium 2 oxide because the same iron still have what 3 oxide. Do you understand? That is it. If for example, let's take what for, let us say copper, Cu and what an oxygen, right? Now copper have 2 oxidation states, either copper 1 and copper 2. So now let us say we are using what copper 1, which is what Cu plus. This is called copper 1, and here we have O2 minus. Is okay. Hope you understand now. So now let's try the Ionic formula. Let's write the Ionic formula. So it's going to be Cu, which is what 1, O, which is what 2, right? This guy move here and this guy want to move here, right? What are you going to get? You're not going to get Cu2O. Is okay. Then the copper that form this compound here is copper 1. Understand this here. The copper that form this guy is called copper 1. What would that be the name of the compound? It's going to be copper 1 oxide. Copper what? 1 oxide. Now, what about if it's copper 2? So you have Cu2 plus and O2 what minus. What are you going to happen here? We have Cu2O, which is what 2, right? Remember 2 go to here, 2 go to here, right? What do you have here? This guy move here and this guy want to move here. What do you have here? We have Cu1O1, right? But there's no point of putting the 1, so we just ignore it, right? So what is that the name of this compound here? The copper that undergo this compound, that form this compound is called copper 2. So now it's going to be copper 2 oxide. This is that. Now, so many students, when they give this guy and this guy here, so many people name some as copper 2, why not as copper 1? But no. Now, those that don't understand are they combine. Yes, copper 2. The reason why it's copper 2 because yeah, 1 is here, 2 is here. This will move here, and this will move here. This 2 we are seeing here is as a rate of oxygen that move here. That's why it's called copper what? 1. Copper 1 is one that form this compound here. But the other one here is called copper 2. So here we have 2 plus and 2 minus. 2 will go into 2. Here we now have 1. So this will move here, so move here. That will form so here. So indirectly, copper 2 is what form this compound. Do you understand? Now we also have iron. We also have iron 2, iron 3, which I have explained here, and the rest of them. This is that. So what I want to do here, I want to what? Place. I want to place a. So what I want to do here is to pause this video here and name all this one for me. It's okay. Go ahead and name this one for me. Pause the video and name these guys for me. Let me see here. If you need the correction to this, you do like comment section. But go ahead and name this one for me. I will check if you are correct or not just now. So next we want to look at is what's called polyatomic ions. So let me drop some polyatomic ions on the board so that I will show how they be formed and I can name them. Do you understand? Polyatomic ions. So these are the common polyatomic ions. So what I want to do here is what? Copy all this here we have NH4 plus called ammonium, right? The name of NH4 plus is called ammonium. Here we have NO2 minus. Here we have NO2 minus. NO2 minus called nitrite. Right there. Then you have NO3 minus called nitrate. So nitrite, SO3 2 minus called sulfate, SO4 2 minus called sulfate. So please differentiate the two of them. They are very, very important. Then you have HSO4 minus called hydrogen sulfate. OH minus called hydroxide, right? CN is called cyanide. It's called cyanide. PO4 3 minus called phosphate. CO3 2 minus called carbonate. HCO3 minus called hydrogen carbonate. ClO minus called hypochlorite. ClO2 minus called chloride. ClO4 minus called perchlorate. CrO4 2 minus called chromate. CrO2O4 2 minus called dichromate, right? So what I want to do here is what? Copy this outside your note because you are going to use them when you are writing polyatomic ions, right? So now let me give you some few examples here. For example, you have Ca2 plus combining, and then also is combining to what? OH minus. Here we have OH what minus, right? So how do you write the ionic compound here? It's very easy, right? So I'm going to show you how to write the ionic compounds and the name, right? So now going to be Ca, which is what? Is 2. Is okay. Now this OH, this will always be in bracket like OH here have what 1 because it's being treated as 1. So this OH here, there always a bracket here that is represented as what as 1 because there are more than 1 now. That's why it's called polyatomic ion. So when you have mono means 1, poly means what? 2 or more. So when you have poly, like 2 or more elements together, atom together, it will always be in the bracket here, or perithesis, that's what they call it. So this guy move here, and this guy will move here. So what would have here now? Ca1. Now you have this one here, OH. Here we have 2. Can you see that? So, but there's no point of putting this one here, so you can just ignore it. What is the name of this compound here? The name of this compound is called calcium hydroxide. Calcium what? Hydroxide. So that is the name of this compound, calcium hydroxide. As it as that, calcium hydroxide. So the name of this one is called calcium hydroxide. So now let's take another one here. For example, here we have Al3 plus, right? Aluminium. Now let's take one of this one here. Let's say here we have NO3 minus. Here we have NO3 minus, right? Now what will happen here is this. We want to combine them together. Here we have Al, which is what is 3. Is okay. There you have NO3. Can you see that? Remember, this 3 here means, now what does it mean here? 1 atom of nitrogen, 3 atom of what? Of oxygen. That is it. So it now be in a bracket like this. Remember, this one, this minus 1. This means what? 1. It's okay. So what happen here? This guy will move here, and this guy will move here, right? So what will happen? Let us say like this, like this. What will happen here? So going to be this one move here. Here we have Al1, right? So move here. So here we have NO3. Here we have what? 3. Can you see that? So what will that be name? Remember, there is no point for this one here, so this one will actually leave out, right? So what will be the name of this compound here? The name of this compound is what? The name of this compound is what? Aluminium nitrate. Because name also call your nitrate. So it's going to be aluminium nitrate. Can you see that? It's very easy. Aluminium nitrate. Okay, now let's take another one. For example, here we have Mg2 plus, and here we have, let us take this one here, SO2 minus, SO3 2 minus, right? Let's take this one here. So what does it mean here? Here we have Mg, which is what? Is 2, right? Here we have SO3 is okay, which is what? Is 2. Can you see that? 2 going to 2, right? When to go into here 1, 2 going to here 1. This one move here, this one move here. What do you have here? It's going to be what? Mg, right? 1, SO3 1. But this one do not actually have effect, so you can just ignore it. Just now, so it's going to be MgSO3. Can you see that? So what is the name? Magnesium sulfate. That is the name. Magnesium what? Sulfate. That is name. That is name. Right? So now what about if you now have polyatomic ions? Where you have polyatomic ions, right? Like so no. So when you have variable oxidation variable oxidation states, metal. So when we have variable oxidation state like copper here, you have Cu2 plus. You now have what? SO3 2 minus. Is okay. So what happen here? You also have what? Cu then plus SO3 2 minus. Right? You see the same thing you did in monatomic and you see the same thing. So you have Cu, which is what? Is 2, right? You have SO3, which is what? Here we have 2. Remember, 2 going to 2, right? 1, 2 going to 2, right? This guy move here. This guy move here. What do you have? We now have what? Cu1, SO3 1, right? But there's no point of putting the 1 here, right? So it will be CuSO3. Now, what would that be the name? Remember, the oxidation state of copper here is what? Is copper 2. So it will be copper 2 sulfite. So the name of this compound is going to be copper 2 sulfite. Just that copper 2 what? Sulfite. Just that. Now, but this one here, what are you going to get here? What are you going to get? Let you manage here. So you have Cu, which is what? 1, SO3 2, right? This guy move here, this guy move here, right? So you have Cu2 SO4 SO3 1. Can you see that? So what do you have here? So you Cu2 SO3. What is the name? The name is going to be copper 1 sulfide. Copper 1 sulfide. Here it's called copper 2 sulfide. Here it's called copper what? 1 sulfide. Just this is that. So that is going to be for this video. That will be what you are going to learn in this video, right? But let me give you some example here, some try so that you solve or name to your convenient time. So So what I want to do is write the chemical formula. Write the chemical formula and name the following pairs of ions. So here we have A, Ca2 plus slash OH minus, right? B, K plus slash SO3 2 minus. C, Fe3 plus slash SO4 2 minus. A, B, C, D, CO2 plus slash PO4 3 minus. A, B, C, D, E. Here we have CO3 plus slash OH minus. So what I'm do here is to write the chemical formula and give the name. So this way we have done what naming simple binary what ionic what compound. All these days helpful. See you in my next video.